I'm Brian with the HVAC School Podcast and HVACRschool.com, and I'm here with Kieran and Jason, and we're going to be doing a full compressor replacement. We're going to be going through it step by step, going through the entire process and making sure that we get it right the first time. So here we go.
So let's go through the different steps all at once of compressor installation. And this is like most things. You create a process and you keep editing it, you keep working on it. I've worked on this process over a number of years, and there's probably still some areas that I can add in, but I'm not saying it's perfect, and it's not going to be perfect for every single application. But the first thing is, before you head to a call, what type of failure was diagnosed? So was it a open winding, open thermal overload, a short? Did you have terminal venting where it blew the terminal? Was it locked? Because all of those things are going to tell you what potential things you could run into with the system once you get it started, things you want to check for. So you should always perform an acid test. We do it every time, but definitely if you have a short or terminal venting, you want to perform an acid test. There's a lot of different acid tests on the market. We do tend to use some of the more inexpensive ones. If you want to be really thorough, there's a couple really good ones. Refrigeration Technologies makes some really good acid test kits. Make sure you have the appropriate refrigerant. Make sure you have enough of it. Generally speaking, when you have a compressor failure, I prefer to use virgin refrigerant just because in the process of the failure, there's some, obviously if you have any acid, any fouling of the oil, you don't want that to end up in the new system. So I tend to use virgin, but there's certainly a case to be made for reusing. Do you have a new capacitor that matches the new system? Do you have a new suction and liquid line dryer, biflow dryer for heat pumps? We only put the suction dryer in when we have a burnout protocol, when we see that there is acid. Do you have the test kits, dryers, and acid inhibitors for burnout applications? Acid inhibitors we're going to talk about here in a second. Do you have fittings and copper pipe to properly install the new compressor? A lot of guys, they fail to keep enough copper tubing on their van. That's a big no-no. You got to keep properly sealed pieces of copper tubing on your van. Especially 3/8 up to 7/8 are the most common. So you have 3/8, 1/2 inch, 5/8, 3/4, and then 7/8 are all sizes of tubing that you need to keep. Because you're going to have, discharge line, suction line can vary depending on the tonnage of the compressor, and you need to have all the fittings. I also prefer to swedge where possible on the suction side, especially. I try not to swedge on the discharge side because it can cause a fail point depending on the type of swedge you use. Do you have a new plug or lead kit for the new compressor? Is the compressor warranty? Is the job billing or COD? That's kind of on the business side, but you want to make sure that you're dealing with that.
What type of failure was diagnosed? Do we know?
Question, yes, we do. It was a loud grinding noise.
Loud grinding noise.
As well as he found an internal bypass valve leaking, causing the problem.
Okay, so it was making a loud grinding noise.
Yeah.
And it was an internal bypass. Well, some reasons that can happen in a scroll. You can have a scroll that's running backwards. That can cause that. If it's short cycled, that can cause that. Acid test should have already been performed. Has it already been performed?
It hasn't. Yeah.
It hasn't. Okay, so let's do that real quick just to make sure we don't have acid. I don't think we will. Do we have enough of the appropriate refrigerant to complete the job? Answer is yes. Do you have a new capacitor that matches the new compressor? Answer is yes. Do you have a new suction and liquid line dryer for the system? In this case, if it's not acid, we're not going to do the suction dryer. We're just going to do the liquid dryer. This is a heat pump. You can see that by the reversing valve. And so in a heat pump, the only way to install a suction dryer for any significant amount of time without locking it into cool mode is to install it in the common suction. So if we were going to, put it here, but then that requires full recovery again to replace it, so you don't want to leave a suction dryer in place. So if we were going to place it out here in a heat pump, we would need to make sure that we lock it into cooling mode, and the way to do that in this unit would be to bug orange to red, so just tie them together so that way it would stay locked in cooling mode. But if we don't have acid, then we're not going to do that. One thing that I noticed right away when I look at this is this right here. We've got oil. Quite a bit of oil, so I'm going to look into that too. We always weigh the refrigerant out, and that's on my list, so we'll get to that in a second. Common mistake that techs make is they see this and they think, oh, that's the liquid line dryer, so I'm going to replace that. That is incorrect. That is not the liquid line dryer. That is a discharge muffler, and if you replace that with a liquid line dryer, you risk causing trouble. So we're not going to replace that. Our liquid line dryer is here, and we are going to cut that out. And we are going to go ahead and reinstall a liquid line dryer on the inside as opposed to out here where it runs the risk of getting rusty over time. Just even connecting and disconnecting to a system that has a compressor failure is just smell. If you smell that kind of like biting acid smell, then you know that you're going to need to do the acid protocol. But acid protocol is one of those things, you need to do it if you need to do it. You don't want to do it if you don't need it because it adds a lot of extra steps and a lot of extra expense. Do we have a new plug or lead kit for the compressor? Alright, so there's our plug. Also, pay attention to any manufacturer information. This is a Copeland compressor, so it comes with one set of requirements. Disconnect, lock out the power supply, cover the charge, verify that the power supply has been disconnected, make sure it's fully removed, make sure to remove the compressor mounting bolts, remove the compressor safely, and then follow all the instructions for proper installation.
So before removing the new compressor, confirm the diagnosis of the previous technician. If it was diagnosed as a burnout, check the wires, check the crankcase heater, and check the terminals on the compressor. Saying, again, you want to make sure that there's nothing else that caused the problem. If it was a non-pumping diagnosis, make sure to check that's not actually a reversing valve or a TXV issue. So especially in the case of non-pumping compressor diagnosis, that's a common one where technicians can improperly diagnose that. And so you want to go through and make sure that you agree with that diagnosis before you move forward. Confirm that the compressor you have is a correct replacement and the feet bolts either match or can be adapted. I've seen guys, try to just use 3 or 4 feet bolts. You want to make sure that your compressor is properly mounted to the base, because otherwise you're going to have vibration and eventually you're going to have an issue with the line cracking or some sort of leak. So you want to make sure that everything matches up and then it's the correct compressor. Confirm there's correct voltage, phase, all those sorts of things. Confirm whether the system has a factory hard start kit. If so, it will need to be replaced. So if you have a factory hard start kit, replace it with a new one. And this is something that when you're diagnosing the compressor and you find that it's failed and it has a factory hard start kit, you're going to want to replace it, because you can't fully test the hard start kit until you get the system running. And so you're not going to know if possibly that potential relay stayed locked in and caused the compressor failure on the start winding. So it's just safer to replace it with a new factory replacement. If it has an aftermarket start kit, it must be removed. Now, when I say it must be removed, so remove the aftermarket start kit. You can put in a new one if it's an application that requires it. If it was in there just to get an old compressor, keep an old compressor running, then that's up to your company policies whether or not you put aftermarket hard start kits on new compressors. I don't, as a matter of course, unless it's long line set, hard shut off TXVs. The system is having issues starting.
All right, so the diagnosis was that it was really noisy. So, and you had started it when you first got here, and what did it sound like?
Sounded like a piston beating around inside some walls really bad.
Okay, so we've got a mechanical failure inside this compressor. Something's going on with the scroll itself. We've got some sort of a mechanical issue there. And so with that being the case, we had one technician listen to it. He was measuring some bypass issues. You started it, heard that extremely loud noise. So we're going to go ahead and stick with that diagnosis. But let's now check for acid. Do we have these caps off?
Yes. Yes, they do.
All right. This is a really simple acid test kit made by Hvac Products. It says product is not designed to detect mild organic acids produced from the breakdown of POE oil. It's not going to test for acids that occur over time with overheating. We're checking for a bad burnout, basically. We're going to insert either end for 2 seconds with vapor flow. So I would do it on the suction line. That way we're more likely to have vapor, and just see what we get. 2 seconds on the suction line. 1, 2. All right, I'm not seeing any change in the color. So it would have a significant color change if we had any significant acids. So we're okay to go ahead and start doing our thing without doing the full acid protocol, which means we're still doing liquid line dryer, obviously, but we're not doing any sort of acid inhibitor or scavenger. We're not doing suction line dryer.
Good.
For quick recovery, pulling the Schraders out is I wouldn't say it's a must, but it's a really good practice. And anyway, having them out for your evacuation is good anyway. I'm gonna bubble down that chat lift fitting we got there, because that looks a little suspicious. Oh, you're really pushing there, aren't you? So we've got the Field Piece vacuum pump, and you can actually get this and the MR45, which is the recovery machine we're about to use here, from Tech Tools. Really good. Both really good devices. They're my favorites. That's what we're putting on all the trucks. So this is the MR45, and then I think this is VP85. I need to check on it, but this is an excellent vacuum pump. I really like the way that the ports are on a 45-degree angle. It makes it really easy to access. It's got just a great device. Really simple device. This is the HCFN version. It just does a great job, especially if you've got a nice rig with large hoses. You're not pulling through manifolds. The oil fill is just really big and easy to work with, which is excellent. And then you can take this whole oil reservoir out. It's got a backlight on the oil reservoir. You can see the condition of the oil really well. It's just a really nice tool.
You would get some because it's low pressure. But
Yeah, he was trying to connect the center hose to the tank itself. The tank's not gonna do much in that way. Now, if we wanted to be real fancy, we could use larger hoses. We could do it without using a manifold. But with refrigerant, it's not as critical, and it'll still coming down pretty quick. So we got a fresh tank with 410A tag on it, and so we need a hose, and we also need a scale so we can weigh out what was in it, which will be helpful in diagnosing if maybe an overcharge caused the problem.
So next, fully recover the refrigerant charge and weigh it out. The weighing it out part is important. Now, obviously, when you're doing a retrofit application, you're not going to know exactly how long the line set is, so it's going to be kind of a guess. But when you weigh it out, you're going to have a good idea, is this system significantly overcharged or undercharged? If you find that it's significantly undercharged, then you're going to want to do a leak detection before you move on. If you find that it's significantly overcharged, then you have an idea that may have been a contributing factor to the system failure, and there may be other system issues, like possibly a metering device issue, TXV issue, that could have caused a previous technician to try to overcharge it to get the suction pressure up. So those are things to look for. Unwire the compressor completely and tape wires away from the compressor to prevent damage to them. That's if you're reusing the old leads. If you're reusing, if you're putting in a new plug kit, then you can just pull it all out. Mark the wires as to which terminals they went to for reference. Again, that's if you're reusing old leads. If you're already reusing old leads, make sure to carefully inspect them. Cut both of the lines as near to the old compressor as possible. Unsweating the lines is not recommended, as the old oil will likely catch on fire and possibly cause injury or wire damage. I don't like unsweating lines off of a compressor. I know a lot of you guys do it. I'm not telling you to never do it, but if you do it, make sure that you're wearing proper PPE, safety glasses, gloves, and make sure that you're not trapped in a place where you're kind of standing under your head and then you're going to get stuck in there. You're going to have some phosgene gas likely, even when you fully recover properly. So if you are going to unsweat, then you should definitely purge very well with nitrogen. So purge a lot of nitrogen through that compressor to hopefully displace a lot of that refrigerant, get it out of there. And then it's probably even a good idea to just flow a little bit of nitrogen as well while you're doing that, the 2 to 5 SCFH. Remove the foot bolts. In the case of possible burnout, use an acid test kit to confirm a burnout protocol should be followed. So that's before you remove it. And this is kind of out of order. But again, some acid test kits require that you actually sample the oil out of the compressor. So that's where this order would be correct. You'd actually take some oil out of the compressor, sample it in the test kit, and just see. Probably a good practice. That's actually something, we're not currently doing the full oil test, the more expensive tests. But if you had a short or a blown terminal, this would be the best way to do it, actually test the oil. You can use your senses. If you ever smell a high level of acid and you see that the oil is black and nasty, then you definitely want to follow the burnout protocol. Remove the old compressor carefully. You may use a compressor lift tool to assist. Do not strain your back while doing this. If it's too heavy, call for backup. Seal the old compressor closed by bracing the suction and discharge line to ensure the old oil doesn't spill out. And that's required by almost all manufacturers. If it has rotolocks on it, then what you do is you tape the plugs that came on the new compressor into the old one, tape them in place.
All right, so we are ready to rock and roll. Static pressure are on the tank. We are zeroed out on the scale. Let's do this thing.
Battery charge of 5.83 pounds.
Where is it?
Right there.
There it is, 5.83 pounds.
R410A.
All right, cool. So now we're going to compare what we get out of this thing to what the factory charge is, and that's going to tell us something. We have our air handler, and this is sitting right about up there, so it's really not that far. So maybe we could expect to have a little more than the factory charge, but it shouldn't be significant. While you're recovering, which this field piece makes pretty short work of it, but while you're recovering, it's a good time to go ahead and start cleaning out the drain. It's a good time to clean out the base pan before you start working, but this one's already spotless. We did a maintenance not long ago on it, so we're good to go on that. All right, so you can hear we've got the shop vac on right now, and that's later on in the process. It's actually one of the last things, clean the drain line and drain pan, but it's a good thing to do while you're waiting if your recovery takes 10 minutes or so. It's a good thing to just hop on and get that done. And I'm always looking for signs of oil everywhere. On the evaporator, anywhere I look, I'm always looking for signs of oil and rub out, so that way we can address that while we're in the process of doing everything else. A lot of times you can find the cause of problems just by being really thorough with everything that you check. Now you all know I'm a big fan of AMRAD capacitors. We're doing this compressor replacement, and I always replace the capacitor when we replace a compressor just to be on the total safe side. This is a capacitor that's not too old. It's already been replaced once in 2017, so it's only, you know, a year and a half old, something like that. But I wanted to just check it. One thing I want to show you is that the terminals have no rust, even though there's a few little rust spots on top. The terminals have no rust because these are plated brass, and so they don't rust at all. And I just want to check the microfarad rating of this just to see how it's doing. So this is common here to the compressor side. 45, so it's still right at its rating. And then the fan side is over 5, so again, right at its rating. Really good quality capacitors. I like them, but I'm going to replace it anyway. Alright, so we are vacuuming the drain, and what we do is we run gallons of water through it with the shop vac on. A little bit of cleaner. We're going to use the Refrigeration Technologies pan and drain treatment as well in the pan, just to make sure that, you know, those enzymes will help break it down over time. But Kieran's gonna start cleaning that drain. Kieran's got a little rig here. Oh no, that's your rig. Yeah. No, that's Jason's rig. It's pretty sweet. Yeah, so I never underestimate the visual inspection. Now, this unit is a 2014. It's only 4 years old, and you can see there's a lot of, this is galvanic corrosion, which isn't necessarily a big deal, but of course it looks awful. The evaporator coil is, it's not terrible, but it's in need of a little wipe down. You can see it's got a piston, which whenever I see a unit that's newer like this, that has a piston, I want to look at what the factory piston is, and I want to see if that matches up with the condenser, because if it doesn't, the odds that the installing contractor actually put the right size piston in are pretty much zero. Okay. So it's something to look for, and when we get the recharge out, it's an easy thing for us to address while we're here if it doesn't match up. So we're going to check outside and make sure that it's also a 67. Don't use this toothbrush to brush your teeth. Trust me. We're going to use a little Viper aerosol coil cleaner. It's not required to rinse it. I'm going to rinse it because it's evaporator coil, but it's non-alkaline, non-acidic, so it's not going to cause any corrosion. It's not going to cause any fumes. So it's perfect for this application. We have light soil, nothing serious, but we want to do this before we clean out the drain pan, because if anything comes off that coil, we want it to go down and out. So actually having the vacuum running while we're doing this is actually perfect. So go ahead, it's all you. So now we just gotta let it dwell for 5 minutes or so, and then we can just rinse it off right into the pan. Be careful, because a lot of times those things leak. So this is sort of an ideal circumstance, because we got a drain pan right underneath this thing, so normally you'd need a drop cloth or something of that nature, but so now we're just gonna rinse from the top down, and that'll also help clean the I kind of wiped down with a rag in there, just for up to down motion to get any of the surface soil off without impacting it in. And it looks quite a bit better already. We'll just rinse both sides, and then we're ready to finish the drain cleaning and on our merry way. I like these toolbox looking shop vacs from Rigid because they fit really nicely in the van. So we're about a pound and a half shy from what the factory said. 5.8 pounds, and we only took out 4 pounds 4 ounces, so we do need to do some good leak check once we get to that stage. Alright, so now we're in self-purge. Shop vac's noisy. Alright, we are now in the cut both lines stage. So we fully recovered, we weighed it out, we were a little short. We need to cut both lines, remove the foot bolts. Already did the acid test kit. It's all the removal portion now. Yep, Jason's doing the old prep before cutting. On this, it's going to be a little tricky to cut that discharge line, but I still always prefer cutting it out to unsweating it so that you don't catch your face on fire. You only catch your face on fire once, Jason.
Oh yeah.
Before you decide that it's not fun. Alright, now we are in the all cut out, ready for removal of the bolts. It's like the running of the bulls, only there's no bulls and it's just removing bolts. Strong people annoy me. I was just here like cutting this dryer out, and I look up and this thing's all noisy. I look up, I'm like, hey Jason, you ready to pull the compressor out? And he's like, what did you say?
It's already out.
Yeah, it's already out. There it is. He already pulled it out. Jason's doing a real pretty job of getting all the channels cleaned out of underneath the compressor so that way it doesn't hold water. I went ahead and stuck some masking tape over all the cut lines just so that way, I don't know, just a little paranoid. Just don't want anything to fall on them. I'm going to actually I'm going to check the Teflon seal on this. I'm going to cut this dryer out and put it on the inside just because that's what I do. I'm a nerd. Can't help myself. Oh, another nice thing about cutting off is that now we can pinch these and braze them shut a lot easier, because that's part of the requirements for return. And this is a warranty compressor, so that's important. So we are using the Viper pan and drain treatment in place of pan tabs. It's not going to get stuck and clog up the drain. It uses enzymes to help break down junk that could grow in the drain. So all we're going to do is just spray down the drain pan edge there, and then just the first row or so of tubing. Alright, that's basically it. It's a nice little coating on the drain pan. You can kind of see the shininess there in the edge. And then the first row of tubing, and that helps prevent the gross stuff from growing. And it smells great. And it's safe. And it's got a big snake on the front.
Aggressive.
And Karen likes it. And once again, I walk upstairs to film something real quick, and I come down and the compressor's installed. I don't know, these Illinois boys are they're too fast. So we're now in the tighten down the bolts portion of the process, which seems like sort of obvious, but a lot of technicians I've seen over the years don't take that very seriously, and it can lead to vibration, which can then lead to additional issues.
Remove any old liquid and or suction line dryers that exist from previous work. Some systems may have factory dryers that should also be removed. That includes, in the case of the compressor, that includes factory dryers. Like with Linux, it's by the heat mode TXV in the outside unit. In the case of a heat pump, you got to remove those. I generally, if the factory has them in sort of nasty, hard to get to places, I'll usually cut them out, straight pipe them, and then put the dryer. Usually I like to put them inside at the evaporator coil, although putting them at the condenser and the liquid line is also perfectly good in many cases. I just prefer to put it inside for many reasons, including so that it doesn't rust. Do not confuse the discharge muffler with the liquid line filter dryer. That's important. The discharge muffler needs to be left in place. Don't confuse that with the liquid line filter dryer. Before cutting out any components, pre-clean the area you'll be cutting and wipe clean. So you're actually using the sand emery cloth, a Scotch Brite pad or something, and you pre-clean that copper before you cut it. Make cuts with proper tubing cutter and deburr, making sure not to drop any shavings into the system. So when you're deburring, don't get any shavings in the system. Again, deburring is an important practice, But if you're going to risk getting shavings in the system, then I'd rather you didn't deburr. If you have a choice between getting shavings in the system and deburring, I would say don't get shavings in the system. It's an area that I'll be honest, I often forget to do, but it is something that you should be doing. Use caps, plugs, or masking tape to block the open lines while working to reduce contamination. I use blue masking tape. Blue masking tape is not going to keep all the air from getting in the system, but it is just going to reduce the rate. It's also going to prevent maybe any moisture from dripping off, or when you're working, sweat dripping off into the lines, because you don't want that. Flowing low levels of nitrogen while the system is open is a great practice whenever practical. I won't go into that. When you're flowing nitrogen, it's tough when you do a compressor because it wants to flow in both directions, especially when you have it open for the line dryer. So it's something you just got to kind of think through how you're going to flow it. But it is good to have nitrogen flowing the entire time you have the system open, because that helps prevent air from getting in the system. You definitely need to have it flowing when you're brazing. Install a new liquid line or buy a flow dryer in the liquid line, either outside of the condensing unit or next to the air handler. Do not install it in the discharge line near the compressor. Many systems have a discharge muffler near the compressor that looks like a dryer, but it is not. Make sure that the arrow on suction and liquid line dryers is pointed in the direction of flow, so the correct direction. Reinstall the suction accumulator if there is one, and also install the new suction line dryer in case of high acid. Put the new compressor in place, being careful not to strain your back. Pipe in the new compressor. Use heat shield near the compressor to ensure you do not overheat it. You don't want heat conducting into the compressor from your line. So in the video that I did, I used the wet rag product by Refrigerant Technologies to help protect the compressor, and my dryers to keep them from burning the paint so it doesn't rust. But then also using heat shields draped around things to make sure that you're not going to burn in any wires, melt coils, do any of that. Tighten down the foot bolts. Flow nitrogen with 3 to 5 SCFH while brazing with a flow gauge. This means flowing through the system, not brazing under pressure. So you're not actually pressurizing. It has to be open. You should have your Schraders out at this point anyway. Install the new compressor, capacitor, as well as new plug and lead kit as needed. Make sure you have the correct wires on the correct terminals. Replace the contactor if it shows any signs of point pitting, and ensure it and the crankcase heater is wired correctly. Because again, you're wanting to not only replace the compressor, you're wanting to eliminate any of the potential causes of failure.
So now we're removing the old liquid dryer. I'm actually working on that. It's got no old suction dryer. If it did, we definitely need to remove it. We're going to install a new liquid line dryer upstairs at the air handler. Reinstall the suction accumulator if there is one. We don't have a burnout, so we didn't have to do burnout protocol. Put in the new compressor. Jason did that without me even looking. Got a pipe in the new compressor. We're going to use a heat shield wet rag from Refrigerant Technologies to keep from overheating the paint. Tighten down the foot bolts, and then we're going to start our flowing of nitrogen before we start brazing. There we go. So we're going to put a new O-ring in this thing, because this chatlet fitting here, because I suspected, even though I wasn't getting bubbles, but it was just at static pressure, I suspected that this thing might have been burned up, and sure enough, it was. They left it in while they brazed, which is not what you should do, and it is totes melted, as the kids say nowadays in their street lingo. This thing is all melted and worn, so I think I greatly suspected that was the cause of our leak, because if we had oil there. So I cut the whole assembly out. I'm just going to cut this back right at the dryer here and remake. Back to here. Back to where I got my blue masking tape. Nothing like the smell of a little phosgene in the morning. Alright, so I'm using some Nylog here. It's especially good on these chatlet fittings here, on the seal surfaces and on the threads. It just really helps make sure that it gets on there nice and snug and prevents galling, and find that it helps reduce leaks. The old one, the seal was just all messed up, so good stuff. Nylog blue. Now, for those of you out there who are thinking, I would put the dryer on the outside on this house, I don't fault you. I would probably put the dryer on the outside too for most of my career. It's just that I've been preaching and touting the values of putting it on the inside for so much recently that I would be quite a hypocrite if, given the first difficult situation, I left it on the outside. And Kieran's like, does this guy literally just talk all day long? First thing I noticed, got a smoke alarm there. So this is an unoccupied house. If it was an occupied house, I'd probably disconnect it, and I'd probably warn the customer. But since it's unoccupied, it's not gonna. The other thing I would do is push that float switch down before we forget and leave it in that upwards position where it's not going to work properly. Right there. Now, a little bit down. Right there. A little bit up. Right.
Trying to get us flat.
Right there. Yeah, perfect.
Good.
Beautiful. Beautiful. All right. Let's do this thing. You want me to shut this off? I'm going to shut this off. Karen wants me to shut this off. Let's see what we got here. Looks like Karen did a pretty good job. Didn't want to make him nervous while he was in the process, but we didn't burn the paint, so I think we're good to go. We're gonna use a perfection. We're gonna use a mirror on it, just make sure, but I think we're good.
Bubble, but
Yeah.
other than that, it's pretty good.
I think we're good. Pressure test it and bubble test it. You can see we got that ball just floating. 5 SCFM, that's all you want. Actually, if you can get less than 5 SCFM, that's good. But that flowing of nitrogen makes all the difference in the world as far as the oxides build up. A lot of people are like, oh, you cooked it, because they see the oxides on the outside. But if you're flowing nitrogen, you ain't building up no oxides on the inside. And that's good stuff. That way you can braise, make a good joint, not have to worry. Alright, so we've got design test pressures here of 250 to 450. It's a 410A system. So we're gonna pressurize it up to 300 PSI and then also bubble test our joints. And we'll just make sure we don't have any other leaks.
Pressurize the system with nitrogen by allowing the nitrogen to enter the liquid discharge port. Pressurize to an exact number, usually 200 to 500 PSI, depending on system type and refrigerant, and make note of what it is set to. Your system will give you a test pressure. Bubble test all the new joints and observe concealed areas with a mirror. If the system is held pressure for at least 20 minutes, proceed on. If the pressure drops, first bubble test your gauges and ports, and then proceed to do a deeper leak check. This pressure test is a great time to begin working on paperwork and cleaning up. Now, I will add that the best way to do this is to have your Schraders out and your core remover tools in, and you're pressurizing through those because you're going to need them out anyway later on when you do your vacuum pump. And so then if you valve off right at your core tools to hold pressure and you're measuring on the side of one of your core tools, then it helps eliminate some of the other things. In practice, I often will just use the gauges anyway. Like the Testo 550s have a nice where you can actually look at trends of the dropping pressure. You will, if you're holding standing pressure tests for a long time and the temperature changes, the pressure will change slightly with temperature. I have a calculator on HVACR School in the resources tab that you can use to find how much that may change. But in general, you want to see your pressure hold pretty steady. Check the oil in your vacuum pump for level and clarity. So make sure it's nice, clear, and clean oil in your vacuum pump. Evacuate the system to below 500 microns. Now, this is not a description of exactly how to evacuate. We've talked a lot about this. Use large hoses. Don't use your gauges. Use a micron gauge on your core tools. There's a lot of different articles we've done about that, so this doesn't cover that, but you want to pull it down to below 500 microns at the system, not at your pump, for 10 to 15 minutes and perform an isolation and vacuum decay test for 10 to 15 minutes, ensuring it doesn't rise above 1,000 microns in that span of time. Lower is even better. So this is a very generic process here. Look at the Measure Quick app, by the Hvac app. They're going to give you much more specific guidelines. This is kind of a general guideline for air conditioning equipment. If evacuation stalls in the range of the boiling pressure for more than 10 minutes or rises up to the water boiling pressure during the decay testing, break the vacuum with nitrogen and re-evacuate. So you're trying to discern if it's rising too quickly, if it's decaying too quickly. Is this caused by a leak? Is this caused by moisture in the system? When you change a compressor, you have a lot of volume. There's a lot of oil that you're pulling on, potentially a accumulator. And so it can take time, and it can take a little bit for any entrained moisture to boil off. So it can be, compressors are a little bit more difficult than other types of evacuations. See AccuTools Hvac app and literature for more info on this, because Jim Bergman has a lot of great info on that. But once you get that all done and you've proven that you're clean and tight and dry and no issues, then liquid charge the system by weighing in a factory charge into the liquid line. Never add liquid directly to the new compressor into the suction or discharge ports. Now, discharge port is generally safe because you have a check valve there that's going to prevent it from going back in most cases. But again, I still prefer you to add it into the liquid line. That way you don't have a bunch of refrigerant being added in right on that compressor. If the compressor has a crankcase heater, power on the high voltage with the system off so that the compressor can be warmed up to reduce liquid slugging on startup. Wait for charge to equalize. Then you turn on the system, wait for charge to equalize and compressor to warm. Then run your system with an amp clamp on the compressor, common lead. Make sure the compressor is drawing normal amperage and pressures are normal. If the compressor makes strange noises or draws high amperages, shut it off immediately and diagnose. It's important to turn it on with you there. Don't turn it on at the stat and just kind of meander outside. You want to be there when that compressor comes on. Once the charge is stabilized, set it to factory superheat and subcooling specs. Check the superheat, subcool, head, suction pressure, split, all the stuff you're supposed to check. In addition to that, when you replace a compressor, I want you monitoring your discharge line temperature and ensuring that it doesn't go too high. In most cases, you're going to see, 160, 150 to 180 is going to be pretty common, but you want to make sure it's not going over 220 degrees because that's going to cause oil breakdown inside the compressor. That's a sign of a problem. Check the system in both heat and cool modes according to the type of system, checking against manufacturer recommendations and specs. Clean the drain line and drain pan, observe condensate drainage, as well as check the air filter, evaporator coil, condenser coil, and any other maintenance items before leaving. Just go through the whole thing to make sure there's nothing else going on. And then if the compressor is under warranty or not, you need to make sure to file the claim, tag the compressor properly, and alert the customer, write the invoice, all that when you're done. That is still, as long as that process is, that's still not completely comprehensive. And there's still some variation there, depending on the particular application. But hopefully that was helpful.
Once he gets done brazing, then we're going to pressurize. We're actually going to pressurize up to 300 PSI, test pressure, 410A system, bubble test everything, and probably 15 minutes or so, 15, 20 minutes. And we're going to pull a good vacuum and do a decay test. All right, let's look at Jason's connections. He did a really nice job, actually. I'm proud of him. It's really good. All right, so the flow regulator is off because we're done flowing nitrogen. Now we're gonna go ahead and pressurize her up to try to get it as close to 300 PSI as we can. Jason is connecting up his 550 app, Testo app. All right, there we go, 0 and 0. And let's put it to the liquid side. Within 0.2, and it's showing it on the app. So now we can log that trend. We can watch and see what it does over time. Tell us whether or not we have any leakage whatsoever. Always got to mark down what the cause is. So will not start noisy when running, noisy when starting up. Put it in the old box, so that way we got the old compressor data as well as the new compressor data, and just stick that sticker right on the compressor. Bubble these all up, real good.
You want me to wipe off the camera?
Huh?
Or the mirror?
No, it's alright, I can see. Yep, we're good. Alright, so I always get requests about what our favorite rig is. So here's what we've got. We've got the Field Piece 8 CFM vacuum pump available at TrueTech Tools with offer code GetSchooled for a great discount. We got 2 great big old hoses, which will be better once I get the new AccuTools by our good friend Jim Bergman. But it's a pretty Mac Daddy kit here. 2 big hoses back tied into 3/8 ports right on the pump. And now all we got to do is just connect our micron gauge just on the side port, and we're ready to roll. All right, so we are connected with the Hvac app, and we've got 15 seconds elapsed, so it's already started, but that's all right. We don't mind being a little behind the 8 ball. All right, ready to go. Ready to rock and roll. This isn't plugged in. Oh, there you go. Pulling on the compressor, line set, evaporator coil, the whole thing. It's a good amount of volume that we're pulling on here. So we'll see how long it takes us. Does it show the time elapsed? Oh, it is on the other screen. So we're 2 minutes in, and we're already down to 2,000 microns on a full system volume. That's pretty crazy. So So our saturation for water is already down at 16 degrees Fahrenheit. We're gonna try to. I think we can get this thing down to 300 microns. All right. So now while it's pulling vacuum, we can start cleaning up a little bit and wire up the compressor. That's in the list. We put in our. We're gonna put in an AMRAD Turbo 200, which again, that's a little bit on the overkill side. The capacitor in it's fairly new, but just part of our standard practice is putting a new capacitor in. So we're just gonna follow that here. Finish up a really good solid install. One thing that I always talk about is whenever you clean a condenser coil or do a compressor or anything, I want you pulling the fan shroud off and putting it in the grass, setting it to the side where it's not going to get damaged. Even my own guys will ignore me on this sometimes and try to tip the fan shroud up while they work. I just don't want to see it slip and bend the fan blades or scratch the paint or something, so I just prefer to do it this way. Get it out of the way. We evacuated the system below 500 microns. We're working on that right now. And then we're going to do the decay test. And then we're going to factory charge into the liquid line. We're going to weigh it in. We're going to weigh in a factory charge because our line length is about 35 feet, 35 feet. So that's where we're going to start. This system does not have a crankcase heater. And then we're going to start it up and do all of our run tests. All right, Karen is going to start rewiring. What I'm going to suggest is you never want to have any rub outs.
Yeah.
So you really want to think about where you're going to route it in such a way that you're not going to have any rub outs. So
try and connect these two. Maybe
you try to put them all together. Yeah, I mean, it's a good idea because these are notorious for rubbing out. I want to think about the best way to do this. So, and you definitely want to keep it away from the discharge line. So what I would probably suggest doing is if you take this, put a piece of Armaflex here, and then you can zip tie to that. Just a small piece. You put a slit in the bottom, zip tie to that, and then that gives you a point that then you can kind of anchor everything to out in this area, because now this wire becomes more rigid. If you know what I mean?
Yep. I got it.
This is Kieran's first experience with the Turbo 200.
AMRAD.
AMRAD.
Of course.
You AMRAD.
Product placement.
You am a rad guy.
Oh no.
So what are we doing here?
We are making 45 MFD for the compressor. So I'm just connecting up 20 and 25. Pretty simple stuff.
Man, you didn't even need to like a wiring diagram for that, did you?
Oh no.
And then the 5.
Yeah. And then the 5.
Piece of cake.
Cool. That's it. That's it, right?
That's it. That's it. Beautiful. So I usually will test the microfarad rating of it now, just to be 100% sure that we're in range. So you can grab my Testo 770-3 there, product placement. So yeah, just clip the alligator clip to the center in common. On this meter, it's the same as the ohm scale. There you go. And now just test one of your 2 compressor terminals. 46.23, so we're good. And then check your 5 microfarad. Now there's a low one and a high one on this. So you have one that's more like 4 and the other is more like 6. So we'll do it to the higher of the 2.
Yeah,
that's it. That one was a 7. Wow.
4.8. So I mean.
So try the other one again. Give it a second. See what it is.
5.7.
Oh, 5.7. Yeah, we'll do that one. 5.7 is good. Yeah.
Cool.
Now, first decay test didn't work, but I had the caps off the valves off the top. I think those might have been leaking a little bit, so I put those on with a little nylog. We're down pretty good now. Almost to 300 microns. 392 microns now.
Would you look at this little fella? He's looking pretty good.
Only took 20 minutes.
What's that?
Only took 20 minutes.
Yeah, we got that down in 20 minutes. Okay, it's been a little bit of a struggle, but we're getting there.
This cheeky little fella.
Got done with our decay test, and now we've added in 5 pounds, 9 ounces out of this tank. We had a few ounces in another tank that we used, so we've added that into the liquid line, so that way we don't throw it straight into the compressor. Now we're ready to start her up and test her out. I've got a discharge line temperature sensor in there, the Testo 115, and so we're going to also monitor our discharge line temperature inside at the compressor itself. Alright, start it up. So did you end up getting a new clamp?
I did.
Gotta check this bad boy by superheat method. Primarily. 70-3. Compressor amps are 9.8. You want to check that against the nameplate? Condenser fan is 1.2. 1.1. 9.8 and 1.1. Yeah, so it's rated at 16. So yeah, we're good. It's good to check our incoming voltage too, under load. 234 volts. That's actually kind of low for down here. That's actually surprisingly low, but it's within range. Our discharge line temperature is 160 degrees, so that's good. We're under our kind of our 220 degree area. And now upstairs, Jason is taking a wet bulb temperature using a 605 eyes right at the return. And we've also got a dry bulb probe in the supply to measure our delta T. You know the 550 has a, oh yeah, you're using Smart Probes app.
Mm-hmm.
Smart Probes app has a target superheat built right into it. Did you know that?
No.
Yeah, click the top left. Target
Get
superheat.
out.
Yeah. And so all you got to do is if you're using Smart Probes, you can connect all those. Which that's so really you would use it. You would use it if you had the Smart Probes connected. But if you go down to the bottom left and hit that gear, go to options, I think.
Yeah. Edit view, configure measurement.
Configure measurement, yeah. And that's where you enter your outdoor dry bulb and your return air wet bulb. So you got to change it to
Actually, yeah.
Fahrenheit first. Right now we're running at 17 degree superheat, and that's only going to drop. So that probably means we need to recover just a little bit. What's our delta T? Yeah, it's not
18 degrees.
Delta T is 18?
Yep.
Yeah. We also have a delta T calculator on my site too. But I can tell you that 18 degrees with as high relative humidity as we have is actually a little on the high side, which makes sense. We probably have a little bit of low airflow, which is shocking given the way that supply plenum looks.
Right.
That's what we like to call a joke.
Mm-hmm.
Yes, correct. Very good. High load, I would expect it to be more like 16 right now, but again, we're not going to screw with it.
I got a delta T calculator in my head.
Do you? Yeah, I mean, you actually kind of, people say 20 degree delta T. 20 degree delta T is good at normal conditions. 75 degrees inside, 50% relative humidity. That's where you're going to be in that zone. Again, we run under the delta T calculator in general anyway, meaning we have higher splits because we run 350 CFM per ton here. Because we want more dehumidification, so. Alright, discharge line temperature. Stable, 160 degrees. Yeah, so our superheat is a little bit on the low side. Which again kind of goes along with it having a little bit of low airflow. But I would go ahead and just take that recovery tank out and just recover a couple ounces. We took out another, how many ounces? 8 ounces. We're going below the factory charge in order to hit our target superheat here. So I'm not going to adjust it too much more because there's no real reason. Now that does show us that because we were only about a pound low from the factory charge when we initially checked it. So that tells us we weren't really that low based on what we're ending up setting it here. So we have about 10 degrees of subcool whenever we can actually read it. Jason has the touch on this thing. There we go. Yeah, 8 degrees of subcool. Now, I don't really want to take any more out. Yeah, he's got it on his app here too. Our evap DTD is right at 35 degrees, which is good. Yeah, there we go. Superheat's at, just hit 20. We've got the run time. Everything is within 5 degrees on our superheat. Condensing temperature over ambient is about right. Our evaporator design temperature difference, TD, is about right. Our split is a little high, but we know that it will be the way that the ductwork is and the way that it's the way that we set up our units at 350 CFM per ton versus 400. So I think we're in good shape. I think we're in good shape. We did a good job. We pressurized the system. We bubble tested the joints. Check the oil in the vacuum pump. We pulled below 500 microns and did our decay test. We liquid charged into the liquid line to factory charge. Crankcase heater, we don't have one. We waited for it to equalize, and then we started it up, checked the amperage, made sure there was no abnormal noises. We set the factory superheat subcool specs. It's a piston system. I also checked to make sure that the piston on the outside unit matched the inside unit as far as the rating, so that way we know it has the right piston in it. Check the discharge line at the temperature at the compressor. We did that. Both heat and cool mode, so we do need to do it quick. With the load we have right now, I don't know that we're going to do much other than just shift the reversing valve and make sure that works. We cleaned the drain pan and drain line, and then we made sure to do all the tagging for the warranty to make sure we didn't have any voltage drop under load, but that's not the case. It's just the incoming voltage is kind of low here. We got this compressor installed. Went pretty well. It's a 4-year-old piston system, which I didn't really know that there were that many of them out here. So whenever you're setting the charge on a piston system, it's a little more finicky. You got to set it by superheat, and it takes a little bit of time, but it's working good. And proof positive is that the end of any good job is making sure that it runs and drains before you walk away. That final walkthrough in which I grab some pieces of garbage that we almost left. So that right there is a sign that our evaporator coil is indeed at dew point. I'm Brian with the HVAC School Podcast and HVACRschool.com. Thanks for watching.